Okay, so we're starting chapter 3, which is actually on polynomials, but it starts with quadratics. So section 3.1 is just can you graph a quadratic function, and then we'll get into with 3.2, 3.3, and 3.4, can you graph a polynomial, can you solve a polynomial, those kind of things. Everything that we're doing is a complete review of things that you learned in Algebra 2. Okay, so quadratic functions look like one of these two graphs. So you can have a positive quadratic that's going to open up. You have a negative quadratic that's going to open down. Quadratics, the two we're going to look at, the two forms we're going to look at is standard form and the vertex form. So I guess, what else we need to know? Remember that quadratics have an axis of symmetry that runs through the vertex. It's important that you realize that that axis of symmetry goes through the vertex. Okay, so to graph, they want us to use the vertex and intercepts to sketch a graph of the quadratic, to give the equation of the axis of symmetry, and then use the graph to get the domain and range. So we're just going to find all the info and then make a graph. So first of all, this is in vertex form, and it's called vertex form because it literally hands you a vertex. So this has a vertex at 4, -1. And at any time that you take a number out of parentheses, the sign changes. So vertex form, the generic, was a times x minus h squared plus k. So since this is minus h, then that counts as a positive 4. Okay, so if your vertex is at 4, -1, that means that you have an axis of symmetry at x equals 4, because the axis of symmetry is always x equals the x of the vertex. To find intercepts, you're going to figure out x and y intercepts. I'm trying to think, do I really care to do that? I think that I don't. I think we're just going to make a table. So vertex, axis of symmetry, and then from there you can just make a little table. So if your vertex is at 4, -1, then we need a couple of points on each side. So we'll go 3, 2, and 5, 6. So because a quadratic is symmetric, whatever you get here, you're going to also get here, provided that you have normal spacing, that it's spaced the same, like 3 and 5 are both 1 away from 4. Okay, so to figure out what happens if I plug in a 2, we're going to put 2 in for x, so 2 minus 4 is -2. Square that and you get 4, minus 1 is 3, which means you should get the same thing if you plug in a 6. If we plug in a 3 minus 4 is -1, -1 squared is 1, 1 minus 1 is 0. Alright, so then to graph, alright, so let's see. We have a point at 2, 3. We have a point at 3, 0. We have a point at 4, -1, 5, 0, and 6, 3. And that is going to make this quadratic. Alright, so in the process of our graphing, we did find x-intercepts. We still don't know the y-intercept, but you could find that by plugging in 0 for x. But you don't need those to get a good graph of a quadratic. And I am almost positive that I don't ask you for that on a quadratic one on your test. So we'll just go with find the vertex, axis of symmetry, and make a table. Okay, I forgot domain and range. Alright, so domain for all quadratics is -infinity to infinity. And then the range is going to depend on whether it points up or down. So this picture points up, so it goes to infinity. but it has a low point of -1. So we're going to say start at -1 and go to infinity. Okay, so another example of that, we have to find the vertex, which is nice with the vertex form because it's just opposite of the number in the parentheses, same as the one on the end. So since there's no plus or minus here, it's like there's a plus 0. Axis of symmetry is always x equals the x of the vertex. And then from there, you can just make a little t-table centered around your vertex. So -2, 0, we want to go out from there. So we'll go -3, -4, and -1, 0. All right, so if we plug in, I'm going to plug in the -1 and 0 because they're familiar numbers, in my opinion. So -1 plus 2 is 1. 1 squared is 1 times -3 is -3. And then if you plug in 0, and 0 plus 2 is 2. 2 squared is 4. 4 times -3 is -12. All right, so -4, -12. -3, -3. -2, 0. -1, -3, and 0, -12. So with this one, we actually found a y-intercept and our x-intercept. I'm pretty positive this is not going to be pretty, but we'll pretend. All right, so again, domain is all real numbers. And range for this one, we're going to say start at -infinity and go up to 0 and stop there. Okay, so if they give you vertex form, it's pretty straightforward. If they give you standard form, then it's not as straightforward. You have to do a little bit of work to get that vertex. So what you need to memorize is that your axis of symmetry, you have to find that first when you have a standard form. And you're going to find them if you're in x equals the opposite of b over 2a. So remember that standard form of a quadratic looks like this. So when I say opposite of b, I mean opposite of this term, so -6 over 2 times a, which means the number here, so I understood 1. So we have -6 over 2 or -3. So axis of symmetry is x equals -3, which means that your vertex is at -3 something. Well, to figure out this something, we're going to plug in the -3 to the function. So what's that going to give me? 9 minus 18, so -9 plus 3, -6. All right, so then we can make a table. Your vertex goes in the middle. Some numbers on either side. All right, so again, I'm going to go with -2 and -1. So if I plug in -2, it's going to be 4 minus 12, so -8 plus 3 is -5. We put in a -1, that'll be 1 minus 6, so -5 plus 3 is -2. All right, so -5, -2, -4, -5, -3, -6, -2, -5, and then -1, -2. So we have this little quadratic. All right, so hopefully at this point you're kind of picking up what's going on. So So I want you to pause after this example and work the fourth example and see how you do on your own. So domain, we have negative infinity to infinity. Range, we're going to start at -6 and go to infinity. All right, pause, try the next one, and then, or you can't pause yet, can you? Sorry. Now pause, try this one, and then see how you did. All right, so to get the axis of symmetry, you're going to have x equals -b/2a. So in this case, that'd be +7/2 times -2. So 7/-4, which is, well, like 1 3/4, so -1 3/4, so -1.75. All right, so the vertex is going to be, I'm going to go ahead and use decimals because that's easier to put in my calculator, and that's what I'm fixing to do is grab that. All right, so if we take that -1.75 and plug it into the function, all right, I'm just going to type what I just wrote right there in my calculator exactly like it looks. And I get 7.125. All right, so when I make my table, I'm going to have that vertex in the middle. And picking things that are symmetric around this are going to be a little difficult, but you have a calculator, so you can either try all of them at one time, like just pick numbers, and not worry about symmetry, or you can, and that way you can pick friendly, so you can do like -2, -3, and you can do like -1, 0. And you can plug those in your head, or if you want to stay symmetrical where you only have to plug in 2 numbers, you can use weird decimals and just use your calculator. So I guess I'll do that. So if I go, we'll just go back 1 and call it -2.75, -3.75, and then going up I'll do -0.75, and then positive 0.75. All right, so remember that you have, if you go to, I can't show you my calculator, so I don't have it on my computer, but if you go to y equals and you type in the function, and then instead of putting graph, if you do second graph, it brings you to a table where you can put in the x's that you want, and it will give you corresponding y's. It just saves you some time. But if you don't remember how to do that, it doesn't hurt anything. It's just going to take you a little bit longer. All right, so typing into my calculator is where I'm getting these numbers, and I was just double checking to make sure that my math was solid, and that my numbers were working out. Okay, so I'm not real sure about. Yeah, this last number should be 0.25. And maybe when I wrote it down, I didn't feel like it was right, but then my brain wasn't telling me why it wasn't. All right. Sorry. Okay, so graphing those, we're going to go, obviously we're not looking for perfection when I'm asking you to graph weird decimals. We just need to be in the ballpark. All right, so -3, almost -4. and down to almost -1. Almost -3, and a little more than 5. I'm having a hard time seeing what I'm doing. Okay. And then almost -2, and a little more than 7. And then almost -1 is back here, and 0.25 is down here. Alright, so let's see if I can draw that. I'm sorry that I made you try the crazy one on your own. I hope you did okay. If not, then you just have to look better than what I just drew. Sure. Alright, so domain, -infinity to infinity. And range is going to be -infinity up to 7.125. Alright, I think that is it. Yes, so this is the assignment for Monday. If you have questions, please email me, and I'll be happy to help.